This last example of mean value theorem tells me to use a calculator. You guys can use a calculator, but it is really not necessary. It is just a nice check to use your calculator. I'm going to show you how you can do this without a calculator at all. Anytime they ask you to do calculator problems, they may require you to use a calculator, and sometimes they don't. But as I said, it's just a nice check. What we're going to do is we're going to first find the slope of the secant line. And we'll do that by taking f of 6 minus f of 0 all over 6 minus 0. When I plug in 6, I'm just going to tell you, you get 900. Take my word for it, you guys can check it. Plug in 6, 6 to the 4th minus 2 times 6 cubed plus 6 squared gives you 900. Minus 0 all over 6 minus 0. So what that means is that the slope of the secant line is 150. Now, what it's asking me to do is find and graph the secant line. Well, I now have the slope of the secant line. I haven't written the equation for the secant line. The equation for the secant line can be found by finding a point that's on the graph. So we'll just go ahead and use 0 because that secant line is going through 0, comma something and 6, comma something, and I'll just plug in 0. 0 flat out gives me 0, so that's the easiest thing to find. So the equation for the secant line has a point 0, 0, and we now know that the slope is 150. So I could write y minus 0 equals 150 times x minus 0. So more simply, my equation, my secant line is y equals 150x. So I've taken care of finding the secant line. Now the next thing I'm supposed to do is find and graph any of the tangent lines of the graph f that are parallel to the secant line. So in order to find those tangent graphs or tangent lines to the graph, I need the derivative. So the derivative is 4x cubed minus 6x squared plus 2x. We're going to set this equal to the slope of the secant line. So this is the slope of secant line. Remember, we want them to be parallel, any of the tangent lines to be parallel to the slope, so we're going to set them equal to each other and find out what x values this occurs. Now, in order to solve this polynomial, we want to go ahead and move everything to one side of the equation. This is not factorable, so we need to use our calculator in order to do this. So I said that we wouldn't need a calculator, and I guess I was mostly meaning to the picture part. But we do need the calculator to help us solve for the x value. I'll be happy to show you how to do that if you've not learned how to solve for an x value on your calculator. Just for right now, you need to just trust me in knowing that I use my graphing calculator to find that the x value at which this is equal to 0 is approximately 3.872. When I go ahead and find the point that goes along with this, because I need the equation of the tangent line, I find out that my y value is 123.672. Again, you guys can check all that stuff with your calculator by plugging in 3.872 into this function. I'm not going to take the time to do so on this video. So that means the tangent line equation would read y minus 123.672 equals 150 times x minus 3.872. And I've accomplished my goal. I found the equation for the secant line and I found the equation for the tangent line.